What if everything you've believed about time is a lie? From clocks ticking steadily to calendars marching forward, we assume time flows like a river, consistent, predictable, unstoppable. Yet, science reveals a universe where this river bends, stretches, and even warps in ways our minds struggle to comprehend. Time might not be a steady march at all. It could be a mosaic of experiences, a variable phenomenon dictated by speed, gravity, and the very fabric of reality. Imagine standing at a train station, watching the seconds pass by to you. Each tick is identical, yet somewhere else in the universe, the same moment might stretch, contract, or even blur. What feels absolute in your perception is fluid in the grand cosmic sense. This journey we are about to take will challenge intuition, dismantle common assumptions, and reveal why physicists like Einstein and quantum theorists see time as a puzzle far stranger than fiction. By the end, you won't just think differently about seconds and minutes. You'll question the very nature of past, present, and future. Time is not what it seems, and understanding its true nature may be the most mind-bending adventure you ever embark on. From a young age, we learn to experience time as a straight line. Yesterday leads to today. Today flows into tomorrow, and moments slip away like sand through our fingers. Our brains are wired to perceive time as continuous and predictable. Seconds tick by steadily, minutes accumulate, and life feels linear. This perception is comforting. It gives order to chaos and a sense of control over our existence. But what we feel is not necessarily how the universe operates. Science repeatedly demonstrates that our intuition about time is misleading. While we sense a flowing river of moments, reality suggests a far stranger picture. At the quantum level, events do not unfold in the neat, sequential manner we imagine. At cosmic scales, the passage of time is distorted by speed and gravity. A clock on a speeding spaceship or near a massive star will tick at a different rate than one on Earth, proving that time is not absolute even in daily life. Perception is deceptive. Moments of fear stretch painfully, while joy seems to vanish in an instant. Our subjective experience of time can bend without any physical cause, revealing the gap between our mind and the universe. Contrast deepens when we consider memory. We often recall past events as a sequence, yet neuroscience shows memories are reconstructed, not replayed, meaning the past we remember is not exactly what happened. Our experience of time is filtered, interpreted, and often distorted by the brain, a system that convinces us of a linear flow that may not exist beyond perception. As we explore further, these contradictions will become even more pronounced. The more we rely on intuition, the more the universe challenges it. Time, it seems, refuses to conform to human expectation, forcing us to confront a reality that defies common sense. Albert Einstein forever changed our understanding of time. Before him, time was considered absolute, flowing uniformly for everyone, everywhere. A second on Earth was the same as a second anywhere else in the universe. Yet Einstein shattered this comforting assumption, revealing a reality far stranger than intuition could grasp. Time, he showed, is not a rigid backdrop, but a flexible dimension, intertwined with space itself. Imagine two twins. One remains on Earth while the other travels near the speed of light on a spacecraft. When the traveling twin returns, they are younger than their sibling who stayed behind. This thought experiment, known as the twin paradox, is not science fiction. It is a direct consequence of Einstein's special relativity. Time stretches and contracts depending on speed, meaning your experience of duration is relative, not universal. Gravity adds another layer of complexity. Near a massive object, like a black hole, time itself slows down. A clock hovering close to the event horizon ticks more slowly than one far away. This phenomenon, called time dilation, has been measured with atomic clocks on satellites orbiting Earth, proving that time bends in the presence of gravity. What feels like a single moment on Earth could equate to years elsewhere, challenging our intuitive sense of simultaneity. Einstein's insights force us to reconsider everyday assumptions. The now we experience is not shared universally. Two observers moving differently may disagree about the sequence of events. The linear flow of time is not absolute but subjective, dependent on perspective and position in the cosmos. These revelations bridge seamlessly into quantum theory, where time behaves unpredictably on microscopic scales. While relativity governs the macroscopic universe, Einstein's work highlights the startling flexibility of temporal reality. Our perception of a constant universal clock is merely a local approximation, comfortable but fundamentally incomplete. By understanding relativity, we begin to see time as a dynamic, malleable dimension, not a fixed river. Each second is context-dependent, shaped by speed, gravity, and motion. What feels ordinary to our senses is extraordinary under the lens of physics, revealing a universe far more intricate than our minds were built to perceive. The stage is now set to explore the quantum realm, where time's strangeness deepens and our intuitive understanding is tested to its limits. The universe has only begun to unveil its temporal secrets, and they are far more baffling than Einstein could have imagined. While Einstein revealed time's flexibility on cosmic scales, quantum mechanics exposes an even stranger truth. At the smallest scales, time may not behave at all like we expect. The world of atoms and subatomic particles is governed by probabilities, not certainties, and the passage of time becomes blurred, fragmented, and sometimes almost meaningless. Consider an electron in an atom. It does not move along a defined path like a planet orbiting a star. Instead, its position exists as a cloud of probabilities until measured. Events at this scale do not follow a smooth, linear timeline. They unfold according to quantum rules that often defy intuition. Cause and effect can appear ambiguous, and the traditional arrow of time seems to waver. Even more perplexing is the concept of quantum superposition, where particles can exist in multiple states simultaneously. Until observation, a particle's when and where are undefined. In this sense, time for quantum objects does not tick steadily like a clock. It is a hazy, probabilistic dimension. The universe at this level operates in ways our classical brains struggle to grasp. Contrast this with our everyday perception, where events seem sequential and predictable. In reality, the fundamental building blocks of matter are operating in a realm where time is flexible, uncertain, and intertwined with probability itself. What feels stable to us is, at the quantum level, fluid and unstable. Quantum entanglement deepens the mystery. Two particles can influence each other instantaneously across vast distances, seemingly ignoring the conventional flow of time. Information appears to bypass the familiar temporal sequence, suggesting that at a fundamental level, the universe may not prioritize past, present, and future the way we perceive it. These findings challenge the classical notion of time as a universal, steady march, from electrons to photons. The smallest constituents of reality operate in a domain where time is not a simple backdrop, but an unpredictable dynamic factor. Our intuitive sense of cause, effect, and duration, reliable in everyday life, fails spectacularly in the quantum realm. As we move from the microscopic to the macroscopic, the influence of entropy and the arrow of time begins to assert itself, giving structure to what would otherwise be chaos. Yet even there, the universe continues to defy expectation, revealing that time at its core, is far stranger than anyone ever imagined. Why does time seem to have a direction? Why do we remember the past but cannot remember the future? Science calls this the thin eulero of time U, and at its core lies a principle that governs the universe. Entropy, simply put, is a measure of disorder. The second law of thermodynamics tells us that in an isolated system, entropy always increases. Left alone, everything moves from order to chaos, from structure to randomness, and this tendency gives time its unmistakable direction. Imagine a glass of water carefully balanced on a table. Drop it, and it shatters into countless fragments. The pieces scatter in every direction, the reverse fragments spontaneously reassembling into a perfect glass is astronomically unlikely. This asymmetry, this irreversible progression from order to disorder, is what defines the forward march of time. It is not our imagination or perception tricking us. It is a fundamental law of the universe. Contrast this with our daily intuition. We often perceive certain processes as reversible. A pendulum swings, a ball rolls, a cup of tea cools. Yet even in these examples, entropy is quietly at work. Energy disperses, heat spreads, and perfect reversal is impossible without external intervention. Time's arrow, subtle and unavoidable, operates invisibly behind the scenes, orchestrating the universe's relentless push toward disorder. Entropy connects the microscopic world of particles to the macroscopic reality we experience. While quantum mechanics challenges our understanding of linear time, entropy imposes a practical direction, giving a sense of continuity. Memory itself is a manifestation of this arrow. Our brains record events in a sequence dictated by increasing disorder, which is why the past feels fixed while the future remains uncertain. Understanding entropy reshapes our perception of time. It explains why we age, why events progress, and why the universe itself moves toward an ever-expanding horizon of disorder. Time is not merely a human construct. It is a consequence of the physical universe striving toward equilibrium. As we continue, we will see that our perception of time is not just influenced by cosmic laws, but also by the quirks of our own minds. The universe provides a framework, yet human experience interprets it, sometimes bending it, sometimes distorting it. The arrow of time flows relentlessly, yet how we perceive it is a delicate interplay of physics and psychology. While physics dictates the rules of time in the universe, our brains create their own version, often bending and warping reality. Time, as we perceive it, is not objective. It is filtered, reconstructed, and interpreted by the mind. Moments of fear stretch endlessly, while moments of joy evaporate in an instant. Our perception of duration is a psychological illusion, revealing that the flow of time is as much a product of the brain as it is of clocks or cosmic laws. Experiments in neuroscience show that when attention is focused or adrenaline rises, the brain's internal clock can speed up or slow down. A terrifying fall from a height can feel like a slow-motion eternity, even though only seconds pass. Conversely, when we are absorbed in pleasurable activity, hours slip by unnoticed. Memory also plays tricks. The past feels continuous, yet the brain stores fragments, reconstructing them into a narrative that seems linear. Our sense of temporal continuity is largely artificial, a story told by the mind to make sense of fleeting experience. Contrast the subjective flow with the objective measurements of physics. Atomic clocks orbiting Earth confirm time dilation, while experiments with particles show unpredictable quantum behavior. Our intuitive sense of seconds, minutes, and hours can diverge dramatically from universal time, highlighting a startling gap between perception and reality. Even culturally, time is interpreted differently. Some societies emphasize punctuality and strict schedules, while others view time as flexible, cyclical, or relational. These variations illustrate that our experience of time is deeply entwined with cognition, emotion, and societal constructs, rather than purely external reality. Understanding these illusions reframes everyday life. It explains why vacations feel short, why childhood summers seem eternal, and why trauma can alter temporal perception. Time is not a simple river. It is a malleable, personal landscape, shaped by the brain's interpretation and the universe's laws alike. The interplay between physics and psychology reveals a profound truth. Time is not a singular, uniform experience. It is a layered phenomenon, governed by both cosmic rules and the quirks of human perception, challenging everything we think we know. If time is not the steady river we imagine, could we actually move through it in unexpected ways? The concept of time travel, long a staple of science fiction, finds intriguing hints in modern physics. Relativity shows that speed and gravity warp time, and if time can bend, might it also fold upon itself, creating loops and paradoxes that challenge the very notion of cause and effect. Consider a theoretical loop, a particle or traveler returning to an earlier point in time. This idea, known as a closed time-like curve, is permitted under certain solutions of Einstein's equations, yet such loops immediately raise paradoxes. The grandfather paradox is the most famous. If you traveled back in time and prevented your grandparents from meeting, would you ever exist to travel back in time in the first place? These contradictions suggest that time may not allow absolute reversal, or that the universe has hidden mechanisms to preserve consistency. Quantum mechanics adds further complexity. Some interpretations suggest particles could exist in superpositions across different times, hinting at a fluidity that transcends our classical understanding. Causality, our intuitive sense that causes perceived effects, becomes blurred. Events may not be strictly ordered, and the future could, in theory, influence the past, at least on microscopic scales. Contrast this with our daily experience. We live under the illusion of strict cause and effect, where every moment follows logically from the previous one. Yet physics suggests that on both cosmic and quantum levels, reality is more flexible, less absolute. Time travel may never be practically achievable, but contemplating its possibilities exposes the fragility of our assumption. Even if we cannot physically move backward, the concept of loops and paradoxes forces a reevaluation of temporal reality. It shows that the universe may not adhere to a singular linear timeline, but instead operates as a complex, interconnected web, where moments are interdependent and mutable. Exploring these ideas also challenges philosophical and ethical thinking. If actions could ripple backward in time, notions of responsibility, consequence, and free will take a new dimension. Time, it seems, is not merely a backdrop, but an active, dynamic entity, shaping and shaped by the universe in ways we are only beginning to comprehend. Time is no longer just a philosophical or theoretical puzzle. Modern experiments are bending and measuring it with astonishing precision. Scientists have tested the predictions of relativity and quantum mechanics using tools unimaginable a century ago, and their results confirm that time is far stranger than our everyday experience suggests. Atomic clocks orbiting Earth on satellites tick at slightly different rates than identical clocks on the ground. These differences, imperceptible to our senses, are a direct consequence of both gravitational time dilation and relative motion. GPS systems rely on these calculations. Without accounting for time's flexibility, our navigation devices would quickly become inaccurate. What seems abstract in textbooks has real, tangible consequences in the world we live in. Particle physics experiments further highlight time's unusual behavior. Unstable particles like muons live longer when moving at high speeds than when stationary, confirming Einstein's prediction. Quantum experiments reveal that particles can exist in states that defy linear temporal ordering, suggesting that at fundamental levels, the sequence of events is not absolute but probabilistic. Contrast these findings with human intuition. We feel time as constant and universal, yet reality operates on scales and conditions far beyond perception. The universe functions with a fluidity of time that challenges everything we consider fixed. Even in everyday life, these effects manifest subtly. Clocks on high-speed aircraft tick differently than those on the ground, though only by billionths of a second. Modern research also probes the edge of time's mysteries. Scientists study entangled particles separated by vast distances, observing correlations that seem to transcend classical temporal order. Experiments with extreme gravity near black holes, though largely theoretical for now, predict even more dramatic distortions of time, hinting at a cosmos where moments are stretched, compressed, and intertwined in ways our brains cannot intuitively grasp. These experiments collectively illustrate a universe that operates under rules far stranger than intuition suggests. Time is not a simple, uniform flow, but a dynamic, flexible dimension, measurable yet mysterious, tangible yet surreal. As we confront these findings, our understanding of reality itself expands, forcing a reassessment of what it means to experience the present, recall the past, and imagine the future. If time does not flow the way we perceive, the consequences extend beyond physics into philosophy, consciousness, and the very meaning of existence. What we consider the past, present, and future may be constructs of our minds rather than fixed realities. If events are relative, probabilistic, or influenced by perception, notions of causality and free will take on new, unsettling dimensions. Consider memory. We recall the past as a continuous, coherent narrative, yet neuroscience shows memories are reconstructed, not replayed. The past we remember is shaped by interpretation, emotion, and context. If the past is malleable in our minds and the future uncertain even in physics, then the flow of time we rely on to anchor our lives may be more illusion than reality. Contrast this with human experience. We plan, we anticipate, we reflect, but the universe does not guarantee a linear sequence. Philosophers have long debated whether the present is all that exists or whether past and future coexist in ways we cannot perceive. Physics now provides evidence supporting these radical ideas, blending scientific discovery with age-old philosophical questions. Time's strangeness also raises existential questions. If the universe does not conform to a singular temporal order, how should we measure significance, responsibility, or progress? How does consciousness interact with a universe where time is flexible? Understanding time's nature forces us to reconsider identity, choice, and the boundaries between reality and perception. Ultimately, the philosophical implications of time's fluidity challenge both the mind and the spirit, inviting us to embrace uncertainty and rethink what it truly means to live within the flow of existence. Time is not a simple river flowing steadily from past to future. It is a complex tapestry, a multidimensional puzzle woven from relativity, quantum mechanics, entropy, and human perception. What feels fixed and linear to us is, in reality, fluid, malleable, and astonishingly strange. Seconds stretch and contract depending on speed and gravity. Particles exist in states that defy classical sequence. Memories reconstruct the past, while consciousness interprets the present through a lens of illusion. We began this journey assuming time was a predictable constant, only to discover that every assumption could be questioned. Einstein's relativity revealed that time bends with motion and gravity. Quantum mechanics showed that at microscopic scales, cause and effect are probabilistic, and moments may not unfold sequentially. Entropy imposes direction, yet even it cannot account for the mind's subjective perception, where joy flies and fear lingers. The philosophical implications are profound. If time is flexible, reality is more mysterious than previously imagined. Our understanding of past, present, and future is limited, not by imagination, but by the very structure of the universe. Awareness of this strangeness invites both humility and curiosity, encouraging us to rethink existence, choice, and consciousness itself. Ultimately, time challenges everything we think we know. It is not merely a backdrop for life. It is a dynamic, unpredictable, and awe-inspiring dimension. To understand, it is to glimpse the universe's hidden patterns and to appreciate the delicate balance between perception, reality, and the cosmic dance that binds all moments together.